I'm joining you today, and my name is Nancy Alley, and I'm from UC Berkeley in California at the Space Sciences Lab. So Kyle Fricke, who presented to you yesterday, and Brian Mendez, we are all co-workers working on the WISE NASA mission, Education Public Outreach. So my presentation for you today is using WISE images and creating tours in the Worldwide Telescope. And I'm wondering how many of you, hi Brian, I'm wondering how many of you have ever used the Worldwide Telescope before? A few people have. Okay, how many of you have heard of the Worldwide Telescope and maybe you haven't used it? Okay, excellent. How many of you have already downloaded or used the web client? Okay, a couple of people. So some of you, I've already put this on your table, but for the rest of you, just pass it along. This will give you instructions on, if you have a PC, how to download the software. It's free. It's created by Microsoft Research, and so it's geared towards PCs. But they do have an online web client that you can run online for both PC and Mac. So the sheet that's going around actually was created for classroom use. So it's got some instructions about ask your parents for permission. I think we're probably okay with that. You don't need to go and ask your parents for permission to download.
Thank you.
You're welcome. You have my permission. So just to let you know, the website to go to, I'll pull it up here, is www.worldwidetelescope.org, and there's the install Windows client or run web client. So you can start, if you want to download it or to start running it, you can do that as I'm showing the tour. So basically, I have a lot of handouts that I'll be giving to you as we go through. So I'm going to go through it fairly quickly just because we're running short on time. But to let you know in advance that if anyone has specific questions or wants more information, I'm happy to talk with you during lunch about this. And that there are instruction sheets that will lead you through the process of using the Worldwide Telescope and creating a tour step by step. So everything that I'm showing you here, you don't need to commit to memory right now. Now, what I've done is created a tour of the infrared universe using WISE images, which are available to you for free on the WISE website. You can also create a tour with any astronomical image that has AVM data attached to it. So AVM stands for Astronomy Visualization Metadata. And there's a number of different categories that are included in that. But the key thing for the Worldwide Telescope is that the image needs to have the coordinate system so that you can load it into the telescope and display it on the telescope. Yes?
The normal valid fit header, is that the picture of that?
You can't load FITS images into Worldwide Telescope, but I believe you can take a FITS image and you can turn it into a JPEG and keep the tag for it. And Kyle, do you know, can you speak to that a little more about taking a FITS image and turning it into JPEG? Isn't there a retagger?
This liberator is the way to do that. Yeah, so I can explain more about that. Yeah, so if you convert it to anything using the liberator, it should fall in and so have it over the train file.
Okay, so I'm going to start.
And Nancy,
and
sorry, Nancy, this is.
I do have a time that I'm showing the tour to anyone outside of Berkeley, and eventually I would like to put this through the NASA product review to make it available to anyone. And so I would like to be able to email this tour to you, and if you are willing to open it up and look at it and then email me your comments back about what, if it worked for you, what didn't work, what you think could be improved, what you really liked. So if anyone does not want to be emailed the tour, please let me know. And I will not include you on the email. Otherwise, I'll just send out a group email later on today. And it looks like Brian is saying FITS Liberator translates FITS headers into AVM tags. So yes, what Kyle was saying, FITS Liberator would be the way to go for it. Okay, so let's get started. This tour is just under 10 minutes long. Seeing the invisible.
Sound? Does it have sound?
This does not have sound, but it can. You can add sound to it. I just haven't done that yet. So invisible light, we can see the stars, but there are many things that don't show up in invisible light. So here we're going to shift from visible to infrared using a WISև image of Tycho supernova remnant. Now this is one of my favorite images, which is why I started off with it, because it's so dramatic. You can't see it all in the visible, and in the infrared, we see this dramatic red bubble created by a supernova star. So what is infrared light? Now the purpose of this tour, I should say, is for the general public audience and students to teach a little bit about what infrared light is. So this slide right here is giving some background about what is infrared, about Herschel and his experiments using the temperature in the different colors of the spectrum. Here we've got a chart of the electromagnetic spectrum with the wavelength and showing that visible light is only one tiny part of the entire electromagnetic spectrum. So on the lower energy side of the spectrum, the wavelengths are longer, and that corresponds to cooler temperature. On the higher side, shorter wavelengths, hotter temperature. Infrared has less energy and longer wavelengths and cooler temperature, which makes it useful for looking at the sky, at the universe, because there are a lot of objects that show up in infrared that don't show up in visible. So using infrared light lets us see into and through these objects, such as this nebula here, ASGL 3490. This dust is emitting light in infrared, and so with the WISև detectors, we can see that dust that we can't see otherwise, visible light. So we're shifting over here to some background information about the WISև mission, which Kyle and Brian may have told you a little bit about already. But the WISև mission is an infrared telescope surveying the sky in 4 bands of infrared light: 3.4 microns, 4.6, 12, and 22 microns. So each one of those bands is designed to look at a specific part. It was launched in December 2009 and completed its primary mission in July 2010. And now the first half of the data, just over half of it, is released, and in about a year, the second half. So we're already starting to see some scientific papers come out of the WISև data. Here is an image of the sculpture galaxy created with all 4 bands of WISև. And what WISև has done is to color code these different bands using the same coding every time. So representational color, the color representing a specific band. Blue and cyan represent the shortest of the two wavelengths. And this tends to be the hot stars. Green represents 12 microns wavelength of infrared. And in this case, it's showing some of the emerging young stars in the core and the spiral arm. And then the longest band, 22, is color-coded red, represented as red. And in this case, we're seeing a lot of the dust in the galaxy. Here is one of the best-known objects in the sky, the Pleiades, known in many different cultures around the world. Star cluster, and when we see it in the infrared, you'll start to see all of this dust emerging around the Pleiades. And this actually is not dust that's associated with the star cluster. It's believed that the star cluster is moving through the dust itself. Next up is Alpha Cam, the star Alpha Cam, invisible light, and then when you shift to infrared, look at what appears. This dramatic red shock wave. So the star Alpha Cam is speeding through the sky, and as it does so, it sends out a shock wave, which condenses and emits in the dust, and you can see that in infrared. This one that is different. IC342, a galaxy, spiral galaxy, known as the hidden galaxy because it's hidden behind the Milky Way galaxy. But in infrared, we can see it more clearly. And another example of a galaxy, I like to include this one, the small magellanic cloud, because people often think of galaxies, spiral galaxies, elliptical galaxies, but this is another type, an irregular galaxy. And you may see some streaks in it, and I believe that those are satellite paths that WISև captured, satellites orbiting the Earth.
Do you have your voiceover within WWT?
You can, yes. And so one of the reasons why he's going to use the recording is I'm going to add snippets to this. You can add music as well. I'll talk a little bit more about that when we go through the mechanics of it. Heart and Soul Nebula, cloud of gas and dust. And you use your imagination. You can look at it as a heart. Moving into a planetary nebula. This one is really neat because there's actually two stars, one giant one and one white dwarf. And the giant star is dying, it's puffing off material, creating the green dust, and then the orange represents jets of material coming out of the white dwarf that's interacting with the dust.
That's newly created dust in the planetary nebula? Mm-hmm. The 21 microns red?
Mm-hmm. The green is 12 and the red is 22. So orange, you're mixing it together. DG 129, and then also the star here is Pi Scorpii, one of the claws in the constellation Scorpius. And the fun thing about nebula is that you can imagine what it's like clouds. So we were calling this the farmhand nebula. You can make up your own images with it. Now this is a Wolf-Rayet star coming up here. And in infrared light, we see again this bubble in red. So we're starting to see a theme here of the red dust surrounding objects. In this case, it's a star that's again sending out shock waves.
So dust again?
Dust, yeah. Typically, with WISև images, the red is cooler dust. And the blue represents hotter stars. So here, it's only the infrared image because this is actually an asteroid. And this is a mosaic of images WISև took over a period of time. So each one of those little dots represents one position of the asteroid as it moves in orbit. And finally, our last one here is a comet. And it's a little hard to see on this screen, but you might be able to see a streak of red. That's actually dust from the comet on its previous orbit around the Earth. Pretty amazing. Pretty amazing. So I'm showing you this tour just to show you some of the images that are available to you on the WISև website. You can use any of these images to create your own tour, and also just to show you some of the capabilities of this, of creating tours. So now to get to the tour, you'll send it to me. So what I will do is I will email you the tour as an attachment, and then you would open it up in Worldwide Telescope. So if you just like if it's a Word document and you double click on the Word document and then it opens it up, it would be the same. Now with maps, I'm not sure how it's going to work because I've only ever tested this on PC. So I'm especially interested to hear from those of you with maps on how it works for you. And if you're using the online client, whether it's Mac or PC. I don't know offhand, but I can check. So what I'll do, because that's a concern of, I don't want to overload your inbox, of course. So what I'll do is I'll check on the file size, and after lunch I'll post it up there.
Actually, we can post it on the abstract page of this conference.
Oh, great. Yeah, let's do that.
1.5 meg.
1.5 meg?
Oh.
Yeah, that's small.
We find so many middle school age children love to create something. I think next going off, this person is very good at that.
Yeah.
How long does it take for somebody to want to how long does it take to learn it? Especially quick. And how long would it take to do something very high quality? How long would it take to do something they perhaps?
Okay, so to answer your question, so the question is how long does it take to learn the program and how long does it take to create a tour? First of all, to learn how to use the Worldwide Telescope, I will give you instruction sheets, but like anything of this type of thing, you learn best by just playing around with it. And it's fairly easy to learn how to learn the basics of it. To create a tour, if you want to create a simple tour, it's fairly easy. So to have students do it where they're just putting images in and you're not really too concerned about fading in, fading out, getting everything to move really smoothly, that should be fairly simple. This took me a long time, actually. I'll be honest, it took me a lot longer than I thought it would. And that was because the instruction sheets that I'm going to be giving to you weren't created at the time that I was doing this, so I was trying to figure it out on my own. And also because I wanted to be able to share it I wanted to be able to put it on the internet and email it out and not just have it live on my computer. And there is a process for doing that which took me a while to figure out. So as a warning to you, if you're doing this with students and you just want to have them do it on their own computer or the classroom computer and you're not planning to share it with anyone, that is a lot simpler than trying to what we call host the images. So with that being said, I'm going to start to pass around.
Can I make a correction?
Mm-hmm.
Is this editable? Meaning, if I want to translate it to Portuguese or introduce some comments, is it possible?
That is a good question, and I believe there is. I believe it's in. The tour itself, what I just showed you, is only in English, but I believe that you can change the language on Worldwide Telescope to other languages.
That I know you can.
You can.
You can localize.
And the instruction sheet, what I'm going to show you now.
But I mean your tour. Can I edit your tour?
Oh, yeah.
But
Then now,
can anyone do that? Or
edit my tour? No, I don't believe you can. Let's talk afterwards though, because maybe we could work together to get a different.
In EUHOU page, you have instructions to localize worldwide telescope. This was produced by Les Mankiewicz from Poland. He's working with you guys to localize the worldwide telescope.
Who is that?
Les Mankiewicz.
Oh, I'm not familiar.
Well, it's in EUHOU webpage. You have all the files you need to localize for worldwide telescope. All the instructions.
But that might not change the tour itself.
No. It's just the software.
Right.
That's why I'm asking if the tour is editable, but it seems it's not.
No, like if I email it to you, you can watch it, but you can't change it. That's my understanding. Although play around with it, because that would be something I would like to know.
By email, when you save it, when you're saving it, you can probably email the saved file, so she can open it and work with it. Just don't save it. That's probably
Right. I see what you're saying.
No, it's not the movie file. It'll be there. I think it's edited. It might be nice to have a resource, a download page of the full file that programming. You want to learn the program, you take somebody else's program first. Having some resource of tours you can edit your own language.
Right.
It could be a really valuable contribution.
Right. Well, let's talk further at lunch or at another point about that. So I'm showing you the Worldwide Telescope Ambassadors page, which all of the handouts that are going around now are available on here as well. So you can download them and make classroom copies.
I think I have it. Oh, no.
Get these documents post also?
Yeah, we can post those. I have them downloaded and I can.
Here.
The second one?
Okay, so here we have the WISę homepage, and the part that I want to direct you towards for creating a tour, because you want to get the images, where you get the images from. Here you can get the WISę images from the multimedia gallery, right here. So all of those images that you saw in the tour, those images came from this website here. And what you would need to do to create a tour, the first thing that you need to do is you need to get all your images in one place. So create a file of images. So for example, say you really like Lambda Orion. This is the head of Orion as seen in infrared. So here what you would do is if this was an image that you wanted to see in Worldwide Telescope, you would need to download the image. And you can really choose, you don't want the TIFF file, because the TIFF file won't open up, but JPEG will open up. And usually I choose the media side.
Yeah, that's perfect.
And then you go through the process of saving the pictures. You create however you do normally when you save something off of the internet. In this case, I created a global hands-on universe folder, and I've already actually saved it here, Lambda Orion. So this is fairly straightforward. At this point, what you would do is open up the Worldwide Telescope, and you can do this along with me. if you've got it open. And to import an image, to open an image into Worldwide Telescope, you would go to Explore, and there's a little down arrow right there. Open astronomical image. And then you navigate to wherever it is that you saved your folder. And I don't remember where I saved mine, so I'm just going to open up this one. Now at this point, if the image that you saved does not have the coordinate tag, it will say does not have ABM information. All of the WISę images do, so you don't need to worry about that. Spitzer images, if you go to the Spitzer website, most of those do also. If you've used Spitz Liberator to tag your own images, then that should work as well. And I still have my tour on here. Close that out. There we go. Okay, so here we have the planetary nebula. Now, some of the fun things to do is fade in and out. Here we've got the imagery is the digitized sky survey. That's the background imagery. You can change that to different surveys, but usually the DSS is, if you want to be looking at things in visible light, that's the best one to use.
But sorry, I don't understand. What is the image that I've opened if you put on top of what is already there?
Right, yeah. So the DSS is the background, the sky that you're looking at. And then what you're doing when you're opening an image is I'm going to zoom out a little bit here, and you can see the square.
Okay.
So that square is the WISę that was loaded on. So you're kind of layering on top. Now, to create a tour, so after you've saved your images, you've opened your images up in Worldwide Telescope, to create a tour using these images, you would go to Explore, New, Slide-Based Tour, right here. Collection is useful if you want to share your tour. So this is where I said there's kind of two diverging paths here. If you just want to do it on your computer and you're not planning to share it, you can just continue with slide-based tour. If you want to share it, then what you need to do is you need to create a collection, add the images to the collection, and change the coding for it, which is a more complicated process that is described in the handout that says hosting images. So again, I'm not going to get into that right now, but if you do want to do that, come and see me afterwards and I'll go over it with you. Just for creating a regular tour that you're not sharing, you just go to slide-based tour. You can enter the name, whatever name you want, give it a tour description, contact information, that sort of thing. Catalog objects, so this is where if you wanted to identify the different objects that were included. Beginner, intermediate, advanced. These are mainly information for if you want to share the tour. I'm just going to put in global times on uniform for right now. Okay. Now, for the adding a new slide, you want to start off. And these little tabs on the top, this is where you want it to start and where you want it to end. So for example, say I want it to start, I'm going to zoom way out so we can see the whole sky. And I'm going to click on this little tab. And I'm back again, because that's where it started from. So what I want to do, I'm going to zoom back out again. Then, now, for the Mac computers, it may be a little bit different. But for PC, I'm going to right-click and go to Set Start Camera Position. Then I just want to go to where I want this slide to end. So I'm going to zoom in to where I want it to end. And let's say I want it to end I'm just doing this on the touchpad of my laptop, so it's a little jerky. But you'll see when you play the tour, it will move. It should move from point A to point B. Right. Yes. Yes. So that is determined by the AVM. Okay. So not every image, not every astronomical image has it's embedded into the tagging of the image. So that's why with all of the live images you can do this. With most of the Spitzer images you can do this. But there are other images out there where when you load it, it won't work. And it'll tell you. It'll give you it'll say does not have information. It'll still load the image, but it won't be matching the background sky. So you could have, say for example, if you were loading that Lambda Orionis image, but the background sky is in Scorpius, it would just put it on top of Scorpius, which isn't really, useful. They're not in the same part of the sky.
Can this be used inside of a planetarium?
I believe it can. And I also think that there's a way where you can connect this up to a telescope. But I don't know how to do that.
Yes, you can.
There's telescopes, man, right there. So presumably that's how you do it. Okay, so I'm going to right-click and go to Set End Camera Position. And here it says 0:10.0. So this is the amount of time that this slide will play for 10 seconds. So I'm just going to play from here, and you can see what happens. So it starts out where I said start camera position, it's zooming in, and it'll stop where it ends. Yes, question? 5 minutes. Oh, 5 minutes. Okay. So I think, let's see. There are many different capabilities for this. I think in the 5 minutes remaining, rather than trying to show you the specifics, because you can go and look this up on your own. What I will spend the next 5 minutes doing is telling you some of the lessons learned, some of the lessons that I learned in doing this. Because you won't find that on those handouts. First of all, I would say that if you want to create a really smooth tour, then plan to use a lot of slides. Because as you shift from one slide to another, and this right here is considered one slide, this would be another slide, so you build your tour up by creating a series of slides. And as you shift from one slide to another slide, it takes a little bit of doing to get it to shift smoothly. So for example, the sculpture galaxy, where it started off with the 4 bands, and then it went to the blue, and then it went to the green, and then it went to the red. That took probably about, I'm going to say, 12 slides to do that, to get it to move smoothly from one to the other. And some of those slides were only 2 seconds long. So it takes some fiddling to do it. Now, so my first tip would be think about what you really want to include and how you want it to show up. It'll go by really fast. You start adding up time. When you got 2 seconds, 2 seconds, and 8 seconds, and 10 seconds, all of a sudden you have a 15-minute tour, and now you're looking at cutting things up. So there is a handout that you were given that says tour do's and don'ts, and one of the first things it says is plan your tour ahead of time, decide what you really want to show and what message you want to convey, and I strongly support that. Because what I did was I started off as like, oh, I like this image, I'm going to put it in. I like that image, I'm going to put it in. And before long, I had a 20-minute tour, and I needed to take it all out again to cut it. So I would recommend being very focused. Now, if you're working with students and you just want to get them to look at the images, sure, just put them in, play around with it. You can also add shapes and text. You can add music. You can use master slides to have something stay on throughout the whole tour. Like, I don't know if you noticed, but I have the little WISซี้spacecraft in the corner. And so that was on a master slide that stays throughout every slide that you do. And then I would say, again, I'll repeat, if you want to share the tour, get all of your images together, change the coding, and then create the tour. And this is a lesson learned the hard way. It took me hours to figure out why some images in the tour weren't showing up when I sent them to Brian and Kyle. And I finally figured it out actually just last week. So,
Say that again?
yes. So if you want to share the tour, you have to create your collection, change the coding, which I haven't shown you how to do, but if you want to, I will show you individually. And there's also an instruction sheet. And then create your tour. Because if you create your tour and then change the coding, it's not going to work when you send it to someone else. It'll work great on your computer, but then you send it, email it out, and the person's like, I don't see anything. Right. Yeah. So it's not hard to do. So don't, like, if you're not familiar with coding, don't worry about it, because it's really not that hard to do. It's just a matter of cutting and pasting. But the trick is that you have to do it before you create the tour, not after. Yes.
Can I save this in a MPEG or AVI format and use inside PowerPoint, for instance?
I'm not sure about that. I'm not sure, but I think probably not.
Because with Stellarium and Celeste, you can do that. You can create your voyage, save it as a movie, and include that movie wherever you want.
You could just play it on your PC in capture mode.
You could, yeah.
Yeah, but that's not the cleaner way. The cleaner would be it would allow us to
Make a movie.
Images.
Or make a movie.
Any other questions? Yes. So the Digitized Sky Survey is already loaded into the Worldwide Telescope software. So you don't need to do anything to get that. When you download the software or when you run the web client, the DSS is the default that you use. So it does require, because it is very graphics heavy, so it does require, like if you have a computer that doesn't have very much memory left on it, or if you're running the online web version and your internet connection is slow, you're going to have problems. But well, you're not installing the Digital Sky Survey onto your hard drive. You're installing the software. Right. Yeah, because that's only one of the options. You have all of these other options too. So you have IRAS, you have UMass, and you don't have to install those. You just do the one software, and it's got it all. Any other questions? Yes, I know. You're welcome. Thank you.
In the teacher workshop. Very cool. It's in the asteroid, or WISę asteroid teacher workshop. It's on the web.
Well, I don't know. Maybe we'll look at it.
We saw it. The girls are so crazy. They love the really.
Well, I saw that. I think it was one of the girls from Creed did video. The video. There was something that went out in the news not too long ago.
I'm not sure. We have the Pablo started off with the game and one of those so right now we have we might the one to take care of science. I interviewed for the tour.
So, Rosa, you were too optimistic. Why? Because I will be here just this mood. Because I know that it's nice, but it's too dependent on the web services to have the instrument cannot develop independently. Exactly. It would be nice to have an applet where.
Because I wonder the comparison between the Google Sky, because in Google Sky you can do the same thing, open an image. It is also, I think it's also web-based.
Yeah.
Thank you. Please stand by.